Welcome to Bite-Size Data Science. In this video, I talk about spatial data we can find at the US Census Bureau site. The files are referred to as Tiger files or Tiger-lined shapefiles. Tiger stands for Topological Integrated Geographic Encoding and Referencing. There are hundreds of files available. Let's get into a notebook. I am using the IBM Watson Studio environment to run my notebook. If you are interested, you can find a link in the description on how to create a free account on that platform. Links to the notebook I'm using here are also available in the description. We access Tiger files in video 47, so we already know that these files follow the Shapefile standard. I'm starting the notebook with some information, including links to specific pages and technical documentation that you can review later. The files we are retrieving are actually zip archives since they are shapefiles including multiple files each, as we saw in video 47. The files are divided in categories called layers. Depending on the layers, the data is either the entire United States or is either divided by state or by county. All file names starts with TL_, followed by the year, the subdivision or extend, and the layer name. Here are some examples of layers. We see address range features that is divided by county. The counties themselves are in a single file for the nation, and place, representing cities and towns, are at the state level. For example, a place shapefile for Illinois would be named TL_2019_17_place.zip. Let's get into more details. We use a FTP connection and go to the geo/tiger/tiger2019 directory. This directory includes a set of subdirectories representing each available layer, 43 in total. Since many layers are at the state level, we need to find a mapping between a state name and its code. For this, we can use a reference file as we see here. There are multiple reference files found in the reference directory or one of its subdirectories. There is a reference file for the counties in this directory, but it does not contain the information we need. Instead, we can read the county shapefile. The county shapefile is at the US level, so it only includes one zip archive. To access the shapefile, we go to the county subdirectory and access TL_2019_US_county.zip. We extract the files from the zip archive and we can then access them from the local environment. The first file in the collection I want to mention is the Prj file. It is what's called a projection file that defines a reference system our shapefiles are using. If you get shapefiles from another system, you could then do conversion between reference systems. The GeoPandas interface allows us to read shapefiles in one step. By identifying one file, it assumes the other file's existence. In this example, I am passing the DBF file that contains the metadata. We see here that the metadata was read, but we also have a geometry column that comes from the SHP file. Here's another example. We want to access the place shapefiles that contain the definition of cities and towns. The place information is divided by state, as we can see here. By the way, note that there is one state from the state reference file we read earlier that is missing in the list of place shapefiles, the United States Minor Outlying Islands. I must say I had never heard of that before finding it through this notebook. The name of the file we want to read includes the state code. Here we read the data from Illinois, which is code 17. To better use these files, you may want to look at the definition of each column in the documentation. Here is a quick example of these columns. If we want to use the longitude and latitude in a query, we first have to convert the values from character strings to numerical values. For example, we can find all the cities that intersect with the bounding box that contains Chicago. We end up with 76 values out of the original 1,369. Let's see this visually using a map created with Folium. On the map, we see the bounding box that includes Chicago. We also see the geometry of Chicago. The markers represent the center of the geometries for each city that intersects with the Chicago bounding box. We now have access to 43 layers of geographical data for the United States. We can use it to limit or group the records we want to process. What other operations can we use on spatial objects? This is what we'll talk about in the next video. See you next time on Bite-Sized Data Science, and don't forget to subscribe.